Okay, we are live. So, hello and welcome to the August 2023 SAT live stream. I'm going to be going through SAT practice test 9, and I'm going to do two sections here. I'm going to do the no calculator and the calculator section of this SAT. So, I'll give people a little bit of time here to join in, and then I will get rolling. But to anyone here currently, thank you so much for supporting, and to anyone watching the replay, thank you. And also to anyone taking this particular SAT, good luck. And also, of course, future SATs, good luck on your upcoming exam. So let's just see here. Once again, I'm doing practice test 9, and this test will be in the description below. So I already did this test ahead of time, and I set the timer so that it would be, done right, as if I were taking the SAT myself. And I will be transparent here. I got the 800, but out of the 58 total questions, I did miss one. And I was like, oh, like it was something so silly. But when I get to that question, I will make sure to mention which one it was. But for this particular SAT, they gave allowance for one question wrong to still get the 800. I guess they do that if they make the questions like particularly, awful that year. But going through this, as the teacher, I was a math major. I've been teaching high school math for 10 years. I don't promise to be like, oh, if I took, 100 SATs in a row, I would only get 800s in the math. Like, of course, I'm going to miss one, or two here and there, maybe even three if I'm having like a bad day. But it's, it's like a movement, like you're gravitating towards like doing well on these. So like, yes, like while I did get the 800, like I was happy, but I'm like, oh, I didn't get the perfect, like I know the truth, but it's all right. Like you reflect on it, and then I tell myself, I will point out what the mistake was. It was very subtle, that I will never make that. I will hopefully never make that exact same mistake again. Like that's how I approach these. All right, but all considering, I'm just going to get moving here. So let me just see here. Oh, we have one in the chat. I took geometry regions last week. Still haven't gotten your score yet, which you're a bit concerned. So as Zert, yeah, sorry to hear you didn't get your score yet, but hang in there. In due time, you're gonna know what your score is. So I guess, yeah, patience is the name of the game. I know we live in a time where like information just comes at us so quickly, but just hang in there. I guess like what's done is done. Your score has already been determined. But what you're doing right now, remember, it's you're doing something for the next level. If you're gonna plan on sticking around to watch some SAT math. Alrighty, so this section here, 25 minutes, 20 questions, no calculator. So this section I was actually able to do in like 13 minutes. But when I go through the questions, I'll explain them somewhat casually. Like I'm not going to race through. But this one I was able to do in 13 minutes. And then the longer section, the 55-minute one, or however long it is. Let me just see. We'll zoom ahead a little bit. 55 minutes. I did that one in like 50 minutes. Like I took my time on certain questions to really make sure like I was good. But even so, that one question I missed, it's still haunting me a little bit. When I see the detail, it was very sneaky. But stay tuned. Hopefully that's motivation for people to keep watching. Which one did I miss? Okay, so first one here, what is the value of x plus y? I'm always looking for a shortcut. I'm like, maybe if I add these or subtract them, it'll just give me x plus y. But if I add these right now as is, I get 3x plus y equals 12. And I'm like, all right, that's not helping me out here. So I'm just going to go ahead and go forward with the elimination. So here, I'm going to multiply this first equation here by 2. And that's going to give us 4x, and we'll have minus 2y equals 16. And then the bottom equation is x plus 2y equals 4. I'm leaving that one intact. And now I add these so that minus 2y plus 2y cancels. And I have 5x is equal to 20, which tells me 5 times blank x is equal to 4. But now that I know x is equal to 4, what I could do is I could solve for y, and then that'll tell me what x plus y is. So let's say I plug into this second equation here. So for this, I'll have 4 plus 2y is equal to 4. And now I subtract 4 on both sides. So I'm plugging in x into the second equation. And I subtract, I'll write the result over here. This is going to cancel, this is going to cancel. So I have 2y is equal to 0. So y is equal to 0. So x plus y is just going to be 4 plus 0, which is equal to 4. So 1 is going to be choice B. Okay, so that is our first question here. All right. And yeah, if anyone is taking the SAT tomorrow, the day after this live stream, let me know in the comment section. And I'll just, once again, good luck to anyone taking the test tomorrow. All right, so which of the following is equivalent? So this one, you just got to know how to do polynomial operations. Distributive property first. So that's going to give you 2x squared. And then 2 times minus x gives you minus 2x. And then if we distribute the next part, this is going to give us plus 3x squared. And this will give us minus 3x. So for this, we just have to be skilled with the integer operations. When we do 2x squared plus 3x squared, that one's not bad, that we get 5x squared, which eliminates this one. And there's going to be some extra stuff here. But now for this part, minus 2x minus 3x, this is integer operations. So just know that minus 2x minus 3x, you're doing negative 2 minus 3, which is negative 5. So we get minus 5x, and it's going to match with choice A. So comment section, let's see. Do you have any tips for the reading writing section? This last minute tips, I don't have any magic tricks for reading writing. To be honest, like if I went through reading writing, like I will stay in my lane and teach what I'm comfortable teaching. Like the math, I'm very strong with. The reading writing, like I would have to practice a lot. But at that question, my best advice was that I think back to when I was in high school, and the kids who did the best on the reading sections were kids that read books like recreationally. So if you want to get better at reading and writing, just start reading more books. Like I know, like, hey, I want to do well on the SAT, so you may think, like, what's the last minute trick? But it's kind of hard to like just create like reading comprehension skills overnight. I think the more you read, and you read a variety of stuff, like read stuff you're interested in, but then occasionally challenge yourself to read, like, even it could be something short, like an article, a scientific article or historical piece, like read something that's out of your comfort zone. And the more you read, the better you'll get at the reading section of the SAT. I mean, that's my 2 cents. Like I don't teach English or writing. I do read, like these days I read a decent amount of books. So I know like reading is like, you have to really get skilled at turning your mind like blank. I know like this day and age, like we all have phones. It's like social media. So I know of, just for people watching, like I'm going to go over the time limit for this because I'm answering such a loaded question here. But it's a great question. But you have to be skilled at like clearing out your mind. Because like even when you do math, or like when I play chess, or when I read books, if I have stuff on my mind, it's like I'm not really giving it my all. I'm not giving it all the focus that it deserves, like where I'm diving into the story and really trying to immerse myself. But that comes with more time. Like the more you read, the more you practice anything, like you just want to immerse yourself. But congrats also on getting the 3 self-studying. That's very impressive. I appreciate you giving me the shout out for the AP Calc BC live stream. But your hard work paid off too, for sure. All right, so moving on. So after 2, choice A, which of the following statements is true about the graph of the equation in the xy plane? So slope, y-intercept, slope and y-intercept, I would turn this into the form y equals mx plus b. That's just where my head's going here. So this, I would just kind of do this step in my head, like plus 3x. And I would start this off as 2y equals 3x minus 4. And then from here, just divide everything by 2. Okay, so y equals, and we've got 3/2 x, and then minus 4 divided by 2. So our slope is 3/2, positive slope. So a and b are out. Our y-intercept, our b value is -2, so we have a negative y-intercept. So this is choice D. Okay. Oh, hello at Mohammed. It's 1:41 a.m. in UK. Well, Yeah, it's pretty late. I'm glad you're joining us. Thank you for signing on here. It's nice to have you. So, question four. We've got the front of a roller coaster is at the bottom of a hill. So this one I would just draw like, I don't know, like you got a roller coaster and it's at the bottom of a hill. Okay, so the front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. So that's like a weird wording. The front is at the bottom of a hill and is above the ground. That's like, I think what they mean here is like the front of the roller coaster is here. It's at the bottom of a hill. And like this part here, it's like 15 feet above the ground. Okay, if the front of the roller coaster rises at a constant rate. Oh, constant rate. So this is something linear. Constant rate means linear. 8 feet per second, that's our slope. So it's 8 feet per second. So the slope is 8. And instead of y equals mx plus b, they're using h equals ms plus b. So in the context of this question, it's like just a slightly different equation. Okay, so which of the following equations gives the height h in feet of the front of the roller coaster car s seconds after it starts up the hill? So they told us here like that right now it's 15 feet above the ground. So that's our b value here. Our b value is equal to 15. So if we throw all of this together, this is just writing the equation of a line. We're going to have m is 8, so we have 8s plus the fixed amount here is 15. So it's 8s plus 15. Choice 4 is A. All right, so this is one of those linear equation word problems. Remember, the rate of change, like the slope, is the constant rate of change. Okay, so that's how I know like the 8 is the slope, and this is the b value, the fixed amount. All right, cool. So moving on here. And question 5, the equation above gives the amount C in dollars an electrician charges for a job. So it's another linear equation. They're really having fun with linear equations here. All right. That takes H hours. Okay, so this is the amount they charge for H hours. Miss Sanchez and Mr. Rowland each hire this electrician. The electrician works 2 hours longer on Miss Sanchez's job than Mr. Rowland's. How much more did the electrician charge Miss Sanchez than Mr. Rowland? All right, so for this one, you could pick out random values here, but just know that the rate of change here, like once you have this, so it's starting at 125 and it's going up 75. So it's like 200 and then for 1 hour, it's going to be that. Like the fixed amount, that just means it's going to cost $125 just for the electrician to show up to their house or wherever they live. Okay, so then this up another 75 would be at 275. So if the electrician works 2 hours longer, think about it, it's $75 basically. Let me fix that. So that's $75 for 1 hour. But in 2 hours, like 2 hours more, that would be $150 per hour. Okay, so 5 I just know is choice C. Some people might say, wait, that's confusing. Then just pick out random values. Pick out like, I don't know, h equals 1 and h equals 3. If you plug those into the equation, this also works. You get C equals, let's say I do 75 times 3 plus 125. That's 225 plus 125. See, but then you got to do this without a calculator, and that's annoying. And if you don't know your 75 times tables, play more Monopoly. Yeah, that gets you better at counting by 75s. All right, so this, and so, wait a minute. What did I just... Oh, the total here. Yeah, so that's 350. I just like forgot where I was for a second. All right. And then this one, if we plug in, is 200. And you see if you subtract those, you get 150. All right, so you could just pick out two values for h that are 2 units away from each other and plug in. But also you could just acknowledge that the slope, 75 in the context of the question, means the electrician is charging $75 per hour. So for 2 hours, it's 150. So that's why it's 150 more. Cool. All right, so that is question 5. And if any questions pop up, like by all means, just send them in the chat. I've got 2 monitors, so I'm trying to do my best to look left every now and then to see if there's questions. All right, so 5 is good. Now, the circle above has center O. Now, let's see. we have the length of arc ADC is 5 pi. All right, now this is a central angle, and from geometry, know that central angles are equal to the measure of the arc that they intercept. So I know that x is 5 pi radians. That's just the thought that's coming in. But they're telling us this is 100 degrees. I'm sorry, I shouldn't say this is a 5 pi radians. This angle here corresponds to like 100 degrees, which is like 100 out of 360 of the whole circle. So forget that. Yeah, I was thinking out loud, but I just spoke a little like inside out here. Okay, so x is 100. What is the length of arc ABC? Well, in a circle, there's 360. So if you subtract 100, that means there's 260 left. So here, what we could look at here is, could we just set up a proportion? I'm trying to think about what's easiest. I guess we could just set up the proportion here. Yeah, that's probably the easiest. So you see, like 100 degrees corresponds to 5 pi of the circumference. And then the 260 is going to correspond to x. So this would give us 100x equals 5 pi times 260. And now just divide by 100. Now, a little trick. 100, because it's no calculator, is equal to 20 times 5. So you ready? I'm going to write 5 times 20. And now 5 over 5 cancels. X equals 0 over 0 cancels, because it's trailing zeros. And then 26 divided by 2 is 13. And 13 times pi is 13 pi. So no calculator magic. All right. Hope that one made sense. Okay. So proportions. Don't actually do 5 times 260. That's painful. Leave it in like this factored form here. And then factor 100 so that you could divide nice. All right, cool. Oh, hi at Omniscient Blitz. Nice to have you on. Okay, 8 over x equals 160. What is the value of x? So cross multiply. I recently did a video where I solved 100 linear equations. I did it live. So this is just reminding me of that. Just be awesome at algebra. Like 160 times x equals 8, and then divide by 160. Okay, so these equations, like you should be able to do them in your sleep. If you're showing up to the SAT, like you got to mean business. All right, this is too big. This is too big. 8 over, like that's the thing. These don't make sense. Like it has to be this one. So like you don't even have to bother reducing because these are all numbers bigger than 1, and 8 over 160 is way less than that. If you really want to see where's that value coming from, divide and you get 1 over 20. And 1 over 20 is this. If you don't believe me, 1 over 20, we just do times 5 over 5 is 5 out of 100. And 5 hundredths is 0.05. Okay, so that's where 7's coming from. All right, cool. So moving on here, let's see. We've got, so we got another comment here. So, hey, Vin, took my geometry regents August 17. You passed with a 78. Very, very, very nice. Wow. And you said you got a 31. Wow, your score went up massively. I'm proud of you. That is amazing. Use many of my regents videos to help prepare. No, you owe a big part of it to yourself because you actually sat there with the videos and you worked hard and you brought your score up massively. That is super impressive. I'm very proud of you. That makes me happy to hear that you like challenged yourself and you accomplished something you were working at. Like just the next challenge I'll give you at Doom is to like not like treat every week next year like it's Regents Week, but if you like treat a random week every now and then like it's Regents Week, like you might really surprise yourself in Algebra 2 with how well you do. Okay, so that's it's like a not a study technique, but if you practice like when most people are not practicing, like that'll give you an edge. Like you'll just start to pull away. You'll become like one of the top students in the class. That's one of my favorite things in teaching. Like not that the students who like there are some students who start the year like way up here and they just keep that for like 4 years of high school and they just like you know valedictorians and whatnot. They I call it like they have like the y equals 10 work ethic. You know, like they're just so to go on a tangent for a moment. Their work ethic is like just always up here. Whereas like most students or most of us are like a sine curve, you know? It's like, "Oh, I care, there's a test coming up. Oh, I don't care anymore. Oh, there's a test." So if you just kind of like randomly like take one of these and like just go like y equals 10 for a while and then like you dip and then go like y equals 10 and then you dip, like you'll just changing your pattern a little bit, it'll have like massive like effect on your overall performance as a student. So I challenge people to try that out. All right, so here, what are we doing? Blah blah blah. In the equation above, a is constant. If no value of x satisfies the equation, what is the value of a? Okay, if there's no solution, just know that happens when you have parallel lines. Okay, parallel lines, they never intersect, no solution, and that means they're going to have the same slope. Okay, so I'm just imagining like something simple, like 2x plus 1 equals 2x minus 3. See how these lines have the same slope? So when we subtract 2x on both sides, you get like 1 equals negative 3, and this is not true. So no solution. That's what I'm thinking of here. So when we simplify this a little bit, we get 2ax minus 15 equals, and now this, we got 3x. Let's go back to red here. So we got 3x plus 5x is 8x, and then we got 15 minus 5 is 10. So for this, to kind of highlight that concept that we were just talking about, we would need the slopes to be equal, okay? Because when your lines have equal slopes, they're parallel and they have no common solution between them. They never intersect. So we would need 2ax, let's make that a little neater. We would need 2ax to be equal to 8x. So here, what value of a? Just divide by 2x. Okay, so this is gone, and a is equal to 4. Okay, so an a value of 4 would make these two lines have equal slopes. All right, and you would have no solution. All right, let's see. A system of 3 equations. Okay, so this is the $1 million phrase right here. A system of 3 equations is graphed in the xy plane. How many solutions does the system have? So if it's a system of 3 equations, we need the three graphs to intersect, okay, at the same place. All right, so this is really big. If I color code these, so in blue will be the parabola. All right, in red is going to be this line. And then we'll do pink here. Will be, make this neater. So in pink will be this line over here. But you see the only place that they all intersect is right here. So there's only one point of intersection common to all 3 graphs. Now, someone who's not careful will be like, oh, there's 3. There's this one also and this one, but you got to be careful. Notice that the red, blue, and pink don't intersect here. Only the red and the blue intersect here. And over here, only the pink and the blue intersect. It's where all 3 intersect. All right, so that's why we have one common solution. All right, so this one, ooh, all right, so this is like algebra, but on steroids. All right, so I just got to do it, I guess. Do I? Yeah, there might be a faster way. Is there a faster way? A is equal to 4. I know A is equal to 4. Does that help, though? Is there let's see. AX. Yeah, you know what? I'm just going to work this out. So I'm trying to do this in my head, but there's not like a really, there might be a fast way. So let's see here. AX times 5x squared. If I multiply those two, maybe I'll do this in colors. So AX times 5x squared is 5a x to the third. And then if we distribute here, ax times minus bx is minus abx squared. And then ax times 4 is 4ax. All right, now I will distribute the 3, and I'm going to have to write this most likely under. Oh, Omniscient Blitz. 92 on the geometry regions. Very, very nice. And once again, I appreciate the shout out, but I'm giving you basically all the credit here. But I appreciate you, finding the videos helpful and whatnot. But awesome, awesome work. I'm really proud. It's nice. I that's what I love about YouTube. It's like I have my students in person, but like my online students, it's like I just have like that many more students, which I just think is awesome. Um, so thank you for like being a part of this. 3 times 5x squared is 15x squared. All right, so I'm just trying to view the stream to see if this flies off the, like where this would cut off. All right, it'll cut off about here. I just want to make sure I don't like fly off the page and no one can see this. Okay, so we got plus 15x squared. And then we've got 3 times minus bx is minus 3bx. All right, and then last we got 3 times 4 is 12. And that just ran off. All right, so let me just move this over. Someone had commented the other day saying, hey, like, why don't you try doing this in the exact time that you get? But I kind of like talking to people in the chat too, like as I'm doing this. I promise you, I did this whole section in 13 minutes. Like when I'm going at hyperspeed and I'm not talking to anybody. So yeah. So 5ax to the third. I'll just write that over here. 5ax to the third. And then the x squared terms. You see how there's plus, I'm going to put parentheses here. And then x squared. We have 15 minus ab. Okay, and then we've got plus, I'm going to put more parentheses. So we have x terms. 4ax minus 3bx. So we have to combine the coefficients. That's 4a minus 3b times x. And then the plus 12. All right, I knew that a was equal to 4 right away because with this type of solving, you set the coefficients equal to each other. So 20x to the third has to be equal to this. Okay, so that's just like something I noticed here. 5ax cubed has to be equal to 20x cubed. So you could just kind of like cancel out the x to the third here. And then 5 times blank is 20. A has to be 4. Okay, so a is equal to 4. And then we also have to know what's the value of ab. So now that we know that a is 4, the next one we could set equal, I guess there's a few options here, but why don't we set is, oh, you know what? We didn't even have to, all right, I could have just went right to this one. So this is like one of those things where, okay, so this one actually would have solved it all at once. 15 minus ab has to be equal to negative 9. But if we're solving for ab, I could just go plus 9 on both sides and plus ab on both sides. Okay, so this is a 9 that I'm adding to both sides. So that's going to give me 24 equals AB. All right, so I know I solved for A, so like don't waste your time by doing, all right, 4 times 6, so B is equal to 6, and then multiply. Like this gives you AB all in one shot. So AB is 24, choice C. All right, cool. So moving on, 11. This one you could just plug in. You could sit there and solve, but just know you're going to have to check your answers anyway. So you might as well just plug in. Like, let's say you plug in 0. You get 0 over 0 minus 3 equals 2 times 0 over 2. And that gives you 0 divided by negative 3 is 0 equals 0 divided by 2 is 2. So 0 has to be an answer, which means these are gone. And now you could check 2. So when x equals 2, you're going to get 2 over 2 minus 3 equals 2 times 2 over 2. This cancels. This is 2 divided by negative 1, which is negative 2. That's not true. So 11, I could just see right away is going to be B. But if you want to feel safe, if you have the time, why not plug in x equals 4? So you get 4 over 4 minus 3 equals 2 times 4 over 2. This cancels. 4 divided by 1 is 4. 4 equals 4. This checks out. If you want, you could cross multiply here, and you'd get 2x equals 2x squared, and then 2x times minus 3 is minus 6x. You could do this, and then subtract 2x on both sides, so go with quadratics. But it's up to you. Whichever one you think you could do faster. There's not like one perfect way to get a high score. You just have to be skilled at the math. So here, that gives you x equals 0 from the first factor, and then x minus 4 would give you a root of x equals positive 4. Either way, choice B. All right, so this one, you could start with the answer choices and work back, but dividing these is going to take forever. I think the best way here is to just go 2x plus 1 over 2x plus 1. Okay, so combine these into a single expression. And they're saying x is greater than 0 because x can't be equal to negative half, because that would make that first fraction undefined. So they're kind of like, covering that, part of this question up. So 1 over 2x plus 1 plus, and then you do 5 times 2x is 10x plus 5 times 1 is 5 over 2x plus 1. So now you can add these together. You're going to have 1 plus 10x plus 5 over 2x plus 1. And then 1 plus 5 is 6. So you get 10x plus 6 over 2x plus 1. Okay, so that would be choice D. Cool, 12 is D. All right, so moving on here to question 13. And yeah, once again, thank you to everybody joining here on this live stream. And I will keep saying it, but good luck to everybody taking their test tomorrow. All right, so let's see here. The function f in the xy plane above is a parabola. Which of the following defines f? So, or the vertex. So just know this is testing you on like your knowledge of vertex form. Y equals a times x minus h squared plus k. So the vertex is your hk. So I just know it's going to be something like y equals a times x minus 3 squared plus k is equal to 1. The vertex is the turning point. But when you get there, x minus 3 squared plus 1, that's going to eliminate these two choices. So now you have to think here, which one is it? So then you just pick out a random point. Like let's say you pick out, I guess 4, 5 works. Yeah, 4, 5 is fine. So this means here that f of 4 is equal to 5. So, I could say y equals or f of x equals. So, if we look here, this is our xy. If I plug in, I get 5 equals a times 4 minus 3 squared plus 1. And this gives me 5 equals a times 4 minus 3 is 1 and 1 squared is 1. So I get a plus 1. This will tell me my a value should be equal to 4. So now I have this. That tells me f of x has to be 4 times x minus 3 squared plus 1. So you see, the vertex lets me plug in for this. But then when I know a point other than the vertex on the parabola, it could tell me my a value. Okay, so I plug a random point in to find a. If I plugged in 2, 5, I would get the same answer. All right, either way, I'm going to get choice A. All right. So moving on. Question 14. This one was just sort of painful. You don't get a calculator for this. So this one, what I notice is that these are all graphed. The lines themselves are graphed correctly. See how they all have the same lines. What's different is the direction they're shading. So that's what we have to be mindful of here. So if we take this one out, this one has to be solved for y. I'm thinking y equals mx plus b. That's the concept. Okay, so what I'm looking at here is I go minus 2x. And now this is gone. And we have 3y is less than or equal to negative 2x plus 6. And now we divide by 3 all across. So it's y is less than or equal to negative 2/3 x plus 2. That's the 6 divided by 3 part. So remember, this one, the negative sloping line is the one that's dropping. And then the positive sloping line is the one going up. So notice that it's y. So this one here, I'll write it bigger. Y is greater than or equal to x plus 2. So the positive sloping line, what I'm imagining here, let me think of a spot I could draw this. I guess I could draw it over here. Is the positive sloping line, it's like we're shading above. And then for the negative sloping line, so this one, the negative 2/3 x plus 2 line, we're shading under, y less than or equal to. So then we have to identify what's the overlapping region. And the overlapping region is this portion here to the left. You see how it's like left, up, right, down? It's the portion to the left. So that corresponds here to choice B. All right, so choice B is our solution to 14. All right, same thing here. When we solve for x, we're still going to have to plug in anyway to check our answers. So we might as well just start plugging stuff in. So if you plug in x equals -1, you're going to get the square root of -1 plus 2 equals -1. And this gives you the square root of 1 equals 1, which is true. So x equals -1 is a solution, which means this is out and this is out, because that means -1 is not a solution and this has no solutions, but -1 works. Now we just have to see, does x equals 2 work? And if x equals 2 works, that means it would satisfy the equation. We would have square root of 2 plus 2 equals -2, but square roots will never send out a negative. You know, square root of 4 is equal to +2, not -2. So this one's not true, which means A is out. Choice B would be our answer. All right, so that is the end of the multiple choice questions for section 3. Now we have the, open answer. So question 16. So now, we really got to know the math. All right, and we got to be spot on. This is kind of like all or nothing here. What is the volume in cubic centimeters of a right rectangular prism? So right away, I'm thinking volume equals length times width times height. The length is 4 centimeters. The width is 9 centimeters, and the height is 10 centimeters. So this is a sort of a nice question to start with. We don't actually write the units in. I just wrote the units so you could see they're all centimeters. And we're writing our answer in cubic centimeters. So there's no sneak attack here where they write one of them in millimeters or meters. So this is just kind of straightforward. So I would do this times this first because we don't have a calculator. 4 times 9 is 36. And then 36 times 10 is 360. So you would write that in for your answer. All right, 17. So looking at this one, what is the value of 2x plus 1? What's the nice way to do this? Is there a really sneaky way to do this? Ooh, I see a sneaky way. You ready? All right, don't only go for the sneaky way. Divide everything by 2. And notice what you get. You get 2x plus 1 is equal to 2. So 2. All right, that's a fun way to do this. The safe way. All right, this, I would say, if you do it this way, you should get style points. That should be a thing. They should give you plus 10 towards your 800. Most people are going to do this. They're going to go -2. This is boring, though. 4x equals 2. Divide by 4. X equals 1/2. And then they're going to plug in 2 times x. This isn't bad. I mean, this is also correct. And as long as you get it right, that's all that matters. But this is just so much cooler. All right. That's just my opinion. All right. So moving on here. Let's see. Question 18. We've got this weird looking function here. So this is a graph of the function f. And the function g, not shown, is f of x and then plus 6. So this is going to shift. This is going to send us up 6. What is the maximum value of the function g? All right, well, first look here. The maximum value of this function is 2. That's the highest point. So if we send everything up 6, of 1, 2, 3, 4, 5, they purposefully cut this off. We just have to imagine here that if we take this, so we go like this. Let me draw that one more time. I almost had it. Yeah, that's much better. Okay, and we grab this and we move this up. Let's see, 1, 2, 3, 4, 5, 6. You see how everything that was where this low point here at 0, now is up to 1, 2, 3, 4, 5, 6. Everything gets shifted up 6. The minimum at 0 is now a minimum of 6 for g of x. So this is g of x. So then the maximum, you see how it goes up 2 plus 6, it's going to go up to 8. Okay, so the maximum value is going to be 8. So you're just taking the maximum here, this is the max. And then you're going to go plus 6. Okay, so here you're going plus 6. You're moving it up 6 to 8. So that one's easy if you know what they're asking. Depends on your knowledge of graphs and functions. All right, triangle PQR has a right angle Q. First thing I'm doing is drawing this. Right angles at Q, and then the location of P and R doesn't matter. So PQR doesn't matter. Sine of angle R. So remember SOHCAHTOA. Okay, sine is the ratio of the side opposite. Well, it's the ratio of the opposite side to the hypotenuse relative to the angle you're interested in. So we're interested in angle R right now. So opposite of R would be here, and that's going to be 4. The hypotenuse is always across from the right angle is 5. And you should know for the SAT, this is one of your best friends, okay? The 3, 4, 5 triangle. You should know this. They could also like take this and just double everything and you get 6, 8, 10. So you should know the Pythagorean triples. The other ones, so more thoughts. 5, 12, 13. There's 8, 15, 17, 7, 24, 25. So those are the popular ones. So I just know this is a 3, 4, 5. What is the value of tangent P? So now I'm focusing here. So relative to tangent, this is, relative to angle P, this side here is opposite of angle P. And this side is adjacent to angle P, all right? So it depends on which angle you're looking at. So opposite, tangent is the ratio of the side, opposite of your angle and to the side adjacent to your angle. So tangent of angle P would be equal to opposite of P is 3 over the adjacent side is 4. So 3/4, or you could say 0.75. Last question. All right. So here we have this graph of f of x is linear, and the graph of the linear function g. So let me just fix this. We'll go different colors. So this is f shown above. The function g not shown is perpendicular to f, and it passes through the point 1, 3. Okay, so 1, 3 is here. So just imagine here we're going to have a line that when it crosses this one is perpendicular. Now, if you're a great artist, you might be able to eyeball this, but I wouldn't trust my eyes on this test. So one thing you should know is that, like, if you look at this line, so let me do this in a different color. And I didn't change colors. All right, here we go. Like the function f, for f of x, I'll just box this off. The slope, I'm going down 2 over 1. So that's, think rise over run. My slope, I'm going down 2 over 1. My slope is -2. And my y-intercept, my b value is 3. So f of x, I could actually write the function for it. It's -2x plus 3. But remember from geometry, now I will erase this to make space. But in geometry, we learn that perpendicular lines, their slopes are negative reciprocals of each other. So that tells me here, like if we have f and the slope is -2, I'll even write it as -2 over 1. G, the slope that's perpendicular, is going to be the opposite of a negative is a positive, and then we flip it. We flip it to 1/2. Okay, so that's this part. Now, if you use that, your slope, your rise over run, you're going up 1. So you're going up 1 over 2. That means you're going down 1 to the left 2. Okay, so like this. And if we were to connect these points, let's say like this, you might be able to just eyeball it and say 2.5. But if that bothers you, like it would bother me, to be honest. My slope is 1/2, and I'm passing through the point 1, 3. So what I would do with this information, let me just zoom out. Okay, if I want to like be 100% precise, because seeing is not always believing on this test. Okay, here I would use this formula, y minus y1 equals m times x minus x1, my point slope form equation. Because the point that we're passing through is x1, y1, the point 1, 3. Like that's the one we're guaranteed to pass through. And I would plug that and the slope into this formula. So I would have y minus 3 equals 1/2 x minus 1. And that would give me y minus 3 equals 1/2 x minus 1/2 after I distribute. And then plus 3, but I'm going to write plus 3 as 6 over 2. Because -1/2 plus 6/2 is going to give me y equals, we have 1/2 x plus 5 over 2. And now that's g of x. So I could say g of x is equal to 1/2 x. And I'm going to write 5 over 2 as 2.5. And now they want g of 0. G of 0, I just plug in. It's going to give me 1/2 0, 1/2 times 0 plus 2.5, which is 2.5. Okay, so our solution here, g of 0 is 2.5. So you might have been able to guess here the function value or the y value at x equals 0 is 2.5. But once again, seeing is not always believing. What do I think the hardest SAT topic is? To be honest, I think it's different person to person. But for me personally, it's like the statistics, probability, and stats. Probability not as much, more stats, because I never taught Algebra 2. And there's one unit in Algebra 2 that is like, there's like a probability and stats unit. So I'm just rusty with it. It's not like it's the hardest because it's like objectively speaking the hardest thing to learn. It's the hardest for me because it's the one I have the least current practice with. Like some people might look at, the geometry and say, oh, that's the hardest. But I don't know. I've been teaching AP calculus for a long time. I've taught geometry a few times. Like I'm very comfortable with geometry. Triangle proofs, they don't put those on the SAT, like we actually have to write a proof. But I would say I don't know, because you know what? It's hard to say what the hardest topic is because it's up to the people making the tests which one they make the hardest question that year. Like you could take a geometry question and make it easy. Like, like this could be a question 1 on the SAT. It'd be like, hey, here's this triangle. Let me just see here. So here's a blank page. They're like, here's a triangle. And they're like, this is 30. This is 50. And they're like, what's x? And you're like, x is 100 degrees, or like x degrees. And you're like, let me get rid of I'll get rid of this part. They're like, x degrees, what's x? You're like, oh, x is 100 because it was 180 degrees in a triangle. So it really depends. Vector proof. Is that like the SAT math like subject test? Because I gotta look into those questions. That would be really fun to get good at SAT math again. It's just a matter of practice. Yeah, vectors. I mean, the key for vectors is just really, it's like a lot of trigonometry. Like when you really get into it, just understanding the concept like behind like how you build up to a vector. I would say there, like if you study up in physics, your knowledge in physics will get you better at vectors. I taught physics for 2 years because there was a shortage of science teachers. So I did that for my school. It was so much fun. Like to be honest, I do miss it a little bit. I would love to just. I mean, I love teaching geometry too, but I think it'd be really fun to do AP Calc and physics, like as my 2 classes that I teach. I do miss it. I don't miss the labs because like grading labs were annoying, but I do miss I miss the labs in the sense that they were just like a lot of fun. Okay, so now we are in the 38 questions. We get a calculator. Let me just make sure the calculator is up and running here. Let's see. Yep. All right, I do have a calculator. So I'm using a TI 84 plus CE. And yeah, it's been basically cleared. The only part I might have adjusted already is mode. I went from auto to decimal. I'd rather look at decimals. But one of the traps for the calculator section is don't use the calculator for everything. You don't need it for everything. So, yeah. Moving on. Let's go here. All right. So this one, what value of x satisfies the equation? So you see, even here, my pen is upside down, is just a basic equation. So just solve for x. So 3x equals 24, and then x is equal to 8. All right, so they usually, just like the first part, start off easy, and then depending on their mood, like how soon they want to make it horrible, like they will. All right. Oh, chat, anything? All right, cool. All right, so moving on here. Question 2. 2 units of length used in ancient Egypt were cubits and palms, where 1 cubit. All right, I'm going to write that down. 1 cubit. I'm going to abbreviate too. 1 cubit equals 7 palms like this. The Great Sphinx statue in Giza is approximately 140 cubits long. Which of the following best approximates? So this one, just multiply both sides by 140. All right, so that's 140 cubits. Like this, like there's a direct proportion here. So we could just multiply both sides by 140. And now we just do 140 times 7. Depends what you could do faster. If you could type this faster, then type it. But if you could do long multiplication faster, then use long multiplication. Some people would be like really anxious and they'd be like, wait a minute, I have a calculator. But like, yeah, like if you want, just punch it in 140 times 7. But don't be so anxious when you have a calculator that like 1 plus 1, like, you know, be honest. How many of you, when you have a calculator, will check that 1 plus 1 is still 2? You know, like just trust your math. All right, so here, what is the value of 2n minus 1? So this is one of those like fun questions where here I would cross multiply. I would get 2n is equal to 50. And I want to build up 2n minus 1. So to save time, just subtract 1 on both sides. You might be like, why are you doing that? Remember, this is style points. This is cooler. Okay, so then on the left, I have 2n minus 1, which is exactly what we want. Okay, and that's 49. Now, look, this doesn't always work. Like, don't spend so much time to build this up. Like, you could, of course, like just solve for n. And, you know, that'll also get you the right answer. All right, like some people, the safe way, like the safe way to do this, they would go like, all right, 2n equals 50, n equals 25, and then they plug in 2 times 25 minus 1 is 49. You still get the same answer, but this one's just so much cooler. I don't know. I think so. Which of the following values of x is not a solution? All right, well, just remember square roots, like this has to be positive. Okay, x has to be positive. So -4, this one is not possible. And we can even check it out. The square root of -4 squared equals -4 is not true. Okay, the square root of -4 squared is the square root of 16. And the square root of 16 is not -4, it's +4. So this is the only one that's not true. Okay, this is false. Not true. All right, this one works. Like, you could plug the rest in and they all work. So A is the one that doesn't work. All right. Oh, Robinucci, how you doing? I'm glad you joined here. And yeah, nice to catch up with you. I appreciate you stopping by and saying some cool things in the chat. Hope you're enjoying your summer. Let's see here. All right. Question 5 and 6. So we have a nice graph now. And it's a temperature of a cup of coffee during an experiment. So time since the cup was removed from a heat source. So the cup is, I'm guessing it's like the cup of coffee is cooling down at this like exponential, you know, decay type rate. But it's like capping off here at room temperature. All right, so that's like what I'm getting at just by looking at this graph. And then we have to use this to answer questions 5 and 6. So it's removed from the heat source, left, blah, 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 blah. All right. And for, let's see, 10-minute intervals. Okay, of the following, which best approximates the temperature in degrees Fahrenheit when it is first removed? All right, first removed is time 0. So when it's first removed, that's here. I would say it's like close to 200. So this is like close to 200. So when you look at all the answer choices, like this one's close to 200. This is like way off. All right, 155 would be like somewhere here. See, it's like between 140 and 160. So that's not it. 100 is way too low. 75 is way too low. So 5 is choice D. Question 6, during which of the following, so let's see, during which of the following 10-minute intervals does the temperature of the coffee decrease at the greatest average rate? So this one, when you think average rate of change, just look for the slope. Okay, so look at the slope here. So if I connect these two. All right, so this from 0 to 10 is as steep as it's going to get. Because when you look at the next two, See how like it gets less steep. So this one is the steepest. Like if you were skiing, I don't know, just imagine like this is you, and you're skiing, you would probably be most terrified of, let me just make sure this is all together. Yeah, like if you had a ski down this, like that would be really fast. Like this one, you're going fast, but like this one, you're like flying down. Um, that one's the steepest. That's the greatest rate of change. Now, 30 and 40 minutes, like these over here, let me change colors. See how like from here to here in pink, this is even less steep than the purple. So that's why this is out. 50 to 60, see how it's just like getting less and less steep. 50 to 60 is less steep. And then 90 to 100 is like the least steep out of the other two. So like A, from 0 to 10 is the steepest. It's kind of like, yeah, with exponential decay, let me do this in another color. The slope here gets less steep over time. If it's exponential growth, like I wish that was my bank account, then the rate of change increases over time. But when it's like exponential decay like this, it's decreasing. So 6 is A. All right, cool. Oh, it would be cool if I collaborated with other math channels, Brian McLogan or Organic Chem Tutor. I appreciate that. You putting me even in the same sentence as those guys. To be honest, like I know who they are, of course. They're like my idols on YouTube. I know they're both. McLogan I know is over 1 million subscribers, and Organic Chem Tutor is like basically like 5 million subscribers. That guy is like I would say like the true GOAT right now. He's like the heavyweight champ of math, like of like education YouTube. Like him or Khan Academy. But I don't know, something about Organic Chem Tutor. I just like his style. Like him, I look up to them both a lot. But like, yeah, like I could say nice things about both of those guys. Like they're really great. I would be cool. I could just say like I greatly approve of their channels. I know about them, and those are two guys that I look up to for sure. Like on like the YouTube side, like the education side, like their work ethic is just outstanding. They're just, yeah, they're great at what they do. And that's all I have to say about those two. But thank you, Muhammad, for putting me in the same sentence as those guys. I hope to one day like just pay my dues and climb up the ranks, for sure. So in the figure above, we have AD intersects BE at point C. And if X is 100, so now we label X is 100. And this is that idea, what is the value of Y? So, you know, for this one, you have to know in a triangle, there's 180 degrees total. So that's the three angles have to make 180. So we have 100 plus 20 is 120. And then I'm going to subtract that from 180. And you get 60. So this angle over here is 60 degrees. Okay, and I'll put my little degree symbol here. So these are vertical angles too. So this one is 60. So now we have 60 plus 40. These two together make 100. And then subtract from 180. So you get Y is equal to 80. All right, choice C. So these aren't so bad. Nice. Oh, I'm glad we're following along here in the chat. I like that. It's nice to have people, yeah, joining the fun. So the line graphed here in the XY plane models the total cost in dollars for a cab ride. Let's see, Y in a certain city during non-peak hours, blah, blah, blah. What is the cost for each additional mile traveled in dollars of a cab ride? So this one here is asking you for the slope. What is the cost for each additional? So it's like cost. Yeah, so it's like cost in dollars per mile. So that's see the Y is this and the X is the mile. So it's like dollars per mile. That's the rise over the run. They want the slope. So the slope here, let me pick nice points. Like this one is nice. It's at 5. Let me count. 1, 2. So this is at 513. And then this one here is at, let's see, 0, 1, 2, 3. So just find the slope between those. Y2 minus Y1 over X2 minus X1. So we're going to have 13 minus 3 over 5 minus 0. And that's going to give you 10 divided by 5, which is 2. So 8 should be choice A. Okay, so it is going to be $2 per mile. Cool. All right, let's see. So now we have customers. See, all right. So before, what's my most challenging topic? Probability and stats, because I'm rusty with them. And you normally have to read a lot. And you have to read carefully so that you don't step in any bear traps. Okay, so, oh, take care at Rob Benucci. Thanks for, once again, thank you for swinging by. It's nice to have you on. So let's see. We have customer purchases at a gas station. So beverage purchase, beverage not purchase. Gasoline purchase. All right, so this is like kind of like they're keeping stats here on like who bought drinks and who bought gas. So these are like the possibilities. If they got both, neither, or yeah. So looking at this, on Tuesday, they had 135 total customers, which is indicated here. That's the total. So it summarizes all that stuff. Did they purchase gasoline, a beverage, both, or neither? Based on the data in the table. Okay, so this is all based on the table. What is the probability that a gas station customer selected at random on that day did not purchase gasoline? Okay, so the probability is like let me think about how to think of that. When I think probability, I think like the number of ways, or like the number over the total. So the number of occurrences. I'm trying to think of the best way to say it. I mean, you can even think like the part over the whole. That kind of works here for probability. I think like how many times something could happen out of the total amount. So that's my thought process. But I need the space to write here, so whatever. So here, what is the probability that a gas station customer selected at random that day did not purchase gasoline? So we got to look at how many people did not purchase gasoline. There were 50 total people that didn't purchase gasoline out of the total was 135. So that's why it's going to be choice D. All right, so it's like kind of like one of those, it's like that. See, that's the thing. I'm rusty with the probability. I just know that it's like the number of ways, the number of times something happened over the total, but they're restricting us here. Notice that we didn't care about the gasoline purchase row. It was like, all right, how many people did not purchase gasoline? Over the total amount of people there was 135. So this choice D. Yes, so choice D would be the one here. All right, so question 10. Washington High School some more probability. Randomly selected freshmen, sophomore, junior, and seniors for a survey about potential changes to next year's schedule. Of the students surveyed, 1/4 were freshmen. Okay, so 1/4 freshmen. So freshmen, that's 1/4. Plus 1/3 were sophomores. I'll put SO for sophomore. And then half of the remaining students were juniors. Oh, all right. So that means there's like equal parts juniors and seniors. So there's equal amounts of juniors and seniors, because out of the people remaining, half were juniors. So that means the other half were seniors out of the remaining half. So this one, I would just find common denominators. Times 3/3, that's 3/12 plus 4/12. So this one, yeah, because I don't have to write plus x plus x. 1/4 plus 1/3 is 7/12. So that means like the remaining fraction is 1 minus 7/12. Okay, because like 1 is like 100%, which is like everybody. So that's why I'm subtracting that from 1 to get 5/12. So that's how many people are remaining. Remember, half of them were juniors. So that tells us here like our x is half of 5/12. And if I do half of that, that's 5/24. Okay, so that means seniors are 5 out of 24. So if there are 336 people surveyed, now I will happily use a calculator. We could do, let me just get the calculator over so you can see what I'm writing. So 5 over 24, that's the fraction that are seniors times 336. 70, choice D. Okay, so this is equal to 70. So be good at fractions. So 5/24 are seniors. All right, this one, plant A, B, plant, oof. All right, let's think about this. Plant A is, so this is plant A. I'll just draw it like this. It's 20 centimeters tall. Plant B is 12. And the ratio of A to B. Okay, so A over B is equal to, the ratio of A to B is equal to the ratio of plant C to D. And they're telling us plant C is 54 centimeters tall. What is the height of plant D in centimeters? All right, so just plug everything in. So it's 20 over 12 equals 54 over x. And now 20x equals 54 times 12. Okay, so cross multiply and then divide by 20. So x equals, and then calculator. No point in being a hero here. So 54 times 12, and then divide that by 20. 32.4, choice A. All right, cool. So nice question. That was a good question. All right, let's see here. Biologists found a new species of pale shrimp at the world's deepest undersea vents. All right, I'm just trying to imagine what's going on. So, all right, the vent is like somewhere here. So there's the fish are down here. The vent is 3.1 miles below the sea surface. Approximately how many kilometers below the sea surface is the vent? Oh, so we're just converting here. So this is like an unnecessary word problem. They should be like, how many kilometers is 3.1 miles? But whatever. I guess it's a fun story to go with this. So here, the vent is 3.1 miles below. How many kilometers below is the vent? So 3.1 miles. We just fix that. Make it a little neater. So 3.1 miles times, and we want miles to cancel. So I'm going to put the unit for miles here, the 0.6214. Miles is going to go in the denominator, and 1 kilometer goes up. This conversion factor, remember, 1 kilometer is just about equal to 0.6214 miles. So when you divide equal things like 5 divided by 5, you get 1. So that's why we just do this. So then miles over miles cancels, and now do 3.1 divided by that decimal. So this will tell us how many kilometers we have. So back to the calculator. Okay, so this one is all converting units. So 3.1 divided by 0.6214. And you get 4.988, which is basically 5. Okay, because we're rounding to the nearest whole number. So we're going to get 5. All right, very cool. Question 13, a cargo helicopter delivers 100-pound packages and one. All right, so I'm going to do this. 100 pounds and 120-pound packages. Just labeling it just to get ready. For each delivery trip, the helicopter must carry at least 10 packages. Okay, so I'm going to say there's X of these and Y of these. Something's telling me we're going to need algebra. All right. And let's see. And the total weight of the package. Oh, all right. So this one is a system of inequalities, linear inequalities. So they're telling us the helicopter must carry at least 10 packages. So if there's X 100-pound packages and Y 120-pound packages, X plus Y, there needs to be at least 10. Tells us X plus Y has to be greater than or equal to 10. All right. And then next they're telling us that the total weight can be at most 1,100 pounds. So the total amount of weight from these packages is going to be 100x. Okay, because if let's say we have 500-pound packages, 5 times 100 would give us 500 pounds. Plus the weight of all of the 120-pound packages would be 120 times y, where y is the number of these packages. And the total weight cannot go over 1,100. So this has to be less than or equal to 1,100. So what is the maximum number of 120-pound packages that the helicopter can carry per trip? All right, so for this one, we just have to, I wouldn't graph this or solve it that way, because I feel like graphing this, is graphing this nice? Let me think here. Maybe graphing it is nice. I don't know if that's going to make it easier. I feel like you just plug in here. Let me just do that. All right. So I'm going to make like a nice table here. So X, Y, what is the maximum number of 120 pounds? So that's this column here. See, Y is with this. So maybe I'll color code it. So Y corresponds to this and the 120. Okay, so that's this one. Okay, so that's here. So what is the maximum number of 120-pound packages? Let's say it's 2, then this would have to be 8. Okay, because at least 8, because 8 plus 2 is equal to 10. And then if you plugged in here, you see how you'd have 800, because you have 8 times 100, plus 120 times 2 is 240. And that's going to give us 1040, which is not enough weight. But even so, we need at least 10. So like, let's say I did more of these. Like we could probably do more of these. So 2 is not looking good. What about 4? Let's see 4. If I did 4, remember, I need at least 10. So then let's say this was 6. So then I'd have 6 times 100 is 600. Plus 4 times 120 is 480. And now this would be 1080. But if I wanted to make this 1100, or over, I'm sorry, this has to be less than or equal to 1100, not over. So forget what I said about there, about having to bump this up. Like this works, but you see already 4 is more than 2. So like 2 would be eliminated either way. So sorry for what I just said a moment ago. I guess like thinking out loud sometimes could be tricky. So this has to be less than or equal to 1100, which both of these are. Cool. So let's see what happens if we have 5. So let's say we do 5 and 5. Okay. And these are getting annoying to color code. So 5 and 5. So let's see here. If I did 5 times 120, that's 600. It's like 5 times 12 is 60 with a 0. And then 5 times 100 is 500. Oh, and check this out. This works out to exactly 1100. Okay. So this one, if we add it, is exactly 1100, but that's fine. So this beats out the other one. So C is looking good, but let's see. Does choice D tip us over? So if we go with choice D, let's say 6, then we would need, at least 4 of these. So that would give us 400 pounds, because we do 4 times X is 4 times 100 is 400, plus 6 times 120 would be 720. And this would give us 1120. So we would be over. So this one doesn't work. It has to be C. Okay. I don't know if graphing this would be faster or better. I feel like graphing would take a while. Like I'm also explaining what I'm doing as I do these. So like that, takes time like away from the question. But choice C for 13. Remember, you don't need to spend the exact same amount of time on each question. Like the theme for these, like how I'm able to do these within the time is, let me find a question. Something like, like this question 7, I answer that very, very quickly. So that gives me more time to do a question like this. All right, so that's just kind of like where my head's at as I'm doing them. Company purchased a machine valued at $120,000. It depreciates by the same amount each year, so that after 10 years, the value will be $30,000. Okay, so it's depreciating by the same amount. So it's not exponential, it's linear. So 120 minus, and after 10 years, so like let's say minus 10x whoops, what did I write 120? 120,000 minus 10x, and now it's 30,000. So what is it decreasing by each year? So this, if I do the algebra, subtract 30,000 on both sides. And that kind of algebra I'm just doing in my head. All right, and then plus 10x. Like this, I like almost like don't even bother writing out. So 90,000 equals 10x. Divide by 10. And this tells you x equals 9,000. So 9,000 is being subtracted each time. So minus 30,000 is no good because that's not the rate of change. We have to solve for the rate of change because it's taking 10 years for it to, like, whatever it's decreasing by x, 10 years later, we're down to 30,000. So it's decreasing by 9,000 a year. So the starting price is 120. So it's 120,000 minus 9,000 times t, whereas t is the years. Okay, so that's going to match up. 14 is going to match up with choice B. All right, this one's no good because we're starting at, like, we're starting here. This is like our fixed amount. All right, this is kind of like a y equals mx plus b, or basically is word problem here. So we solved for, it's annoying because I used x to represent the slope. But remember, the SAT, like, you could break the rules. You just got to get it right. All right, line M in the xy plane contains the point 2, 4, and 0, 1. Which of the following is an equation? So write the equation of a line. So slope. So this is x1. Actually, you know what? I'll call this one x1, y1. And this is x2, y2. Because then I won't have to deal with, like, wacky numbers. So m equals 4 minus 1 over 2 minus 0. So this is 3/2. So that's our slope. Conveniently, this is a sneaky, like, almost like a birthday gift for us. They gave us the y-intercept. 0, 1 is on the y-axis. So that's our y-intercept, like, of our line, like whatever this line is. They gave us the y-intercept. So they not only gave us like a point, but they gave us our b values equal to 1. So now I could just use y equals mx plus b. And I could say y equals 3/2 x plus 1. Okay, I could use this formula too, but it's a waste of time. Like, if they give you the y-intercept, use this. All right, this is fast. This still works, but it's slow. All right, let's see. How are we doing in the chat? How can I tell which word inequality? All right, so good question. This is the part of the question where you take your time thinking. So when they tell you, like, you need at least 10 packages, this is like the number of packages. And hello, Fortnite. You're frequent, one of my probably like most enthusiastic supporters. I know you've been commenting on so many of my videos, on a bunch of my live streams. I appreciate the support. So at your question, the number of packages is x plus y. If you need to have at least 10 packages, this means, like, you need like 10 or more. So that's why greater than or equal to, right? Because if you had like less than 10, like, that's not at least 10. Like, if you had 9 packages, that's not at least 10. That's less than. Now, y for the weight. So this is the total weight. They told us the total weight has to be at most 1,100 pounds. This means like at most means no more than. Okay, or less than. Or less than or equal to. All right, so I just like reading it carefully. The more you practice those questions, though, you just kind of get a sense for it. I like almost, I can't memorize like when to use which one. I just think about it carefully. Like, all right, at least. Like, if I had like at least $5 in my wallet, that means I have $5 or more. My wallet is greater than or equal to $5. Like, you just say it to yourself enough times. And that's the way. So cool. All right, so coming back to this one. In the expression above, a is constant if the expression is equivalent to bx, where bx, oh, I'm sorry, where b is constant. What is the value of b? So this entire expression is equal to bx. So I'm thinking here we have to suffer through this and expand this side. Is there a nice way? I don't know. I'm just going to go for it. 4x times ax is 4a x squared minus 4. And then I guess I'll stay in purple here. Actually, no, I'll do this part in red. 4 times ax is 4ax. 4 times minus 1 is minus 4. Okay, and then this stuff here, just write minus x squared plus 4. And then equals bx. So we have to solve for the value of b. So for this one, I would combine like terms. We have this here, which, to be honest, the only thing that matters, let's just see. A is constant. And yeah, no, I'm just going to keep going with this. So we have 4a. Oh, here we go. So when we combine 4ax squared and minus, there's an invisible 1x squared, you combine the coefficients. So it's 4a minus 1x squared. And then this part, we have plus 4ax. And let me just make sure that I don't have anything crazy here. Minus 4 plus 4 cancels. Okay. And we also have... Oh, all right, that's where it was. All right, I forgot to write an x. I was like, wait a minute, something looked funny here. Okay, that's where it was. So 4ax minus 4, the purple stuff. That's why it looked funny. This is this, but 4x times minus 1 is minus 4x. Just forgot to write my x. Something looked funny, though. All right, I'm glad we caught it. So 4ax squared minus... So now this is still 4a minus 1. I probably didn't need to erase all that, but whatever. And now we've got... These two are like terms over here. So minus 4x plus 4ax. Those are both x terms. I'm going to put the plus first. So I'm going to have plus 4a minus 4 times x. So that's those two. And then minus 4 plus 4 cancels. When I saw that I had like 3 constants, I was like, wait, something got messed up. So this wipes out, and this is equal to bx. All right. So now, what you want to see here, this algebra gets a little tricky. There was algebra like this on like AP Calculus in 20... What year was it? 2015. The 2015 test, the differential equations question, they had algebra like this. Notice at the right side, there is no x squared term. It's technically like a 0x squared. So that means this coefficient, 4a minus 1, has to equal 0. Because like there is no x squared term on the right. They said it's just equal to bx. So that means a is equal to a fourth. So now what we could also say here is the x coefficients, 4a, let me do this in a different color. 4a minus 4 has to equal b. Okay, so 4a minus 4 has to equal b. So now we just said a is equal to a fourth. So we're going to have 4 times a fourth minus 4 equals b. And now 1 minus 4 is negative 3. And negative 3 is equal to b. Choice B. Okay? So 16 is B. Tricky question. Hard algebra. Definitely a hard algebra question. All right. System of equations. Ooh, we have a calculator. So, ready? 2w plus 4t equals 14. 4w plus 5t equals 25. All right, we have a calculator. You could solve this by hand, but like, is there a nice... No, let's use a calculator. We have a calculator, so... All right, if you have the TI-84, you get to use this trick. Otherwise, you just have to solve the system like I did in the no calculator section. So I would go to apps, number 9, polynomial simultaneous 2, and simultaneous equation solver, option 2. 2 equations, 2 unknowns, just press graph to go next. And just pretend that's x and y. So 2 plus 4, 14 over here. And then the next equation is 4. I'll say x plus 5, whoops, plus 5y equals 25. And now press graph to solve it. And the solution is 5, 1. Okay, so w equals 5. And t is equal to 1. And you could even check. If you did 10, 2 times 5 is 10, plus 4 times 1 is 14. And 4 times 5 is 20, plus 5 times 1 is definitely 25. So yay, good for the calculator. So now 2w plus 3t is 2 times 5 plus 3 times 1. And that's going to give you 10, whoops, 10 plus 3, which is 13. Choice C. All right, so this is a nice little calculator trick. Which, hey, you're in the calculator section, so like, why struggle? You know, you're allowed to use it. So, all right, 18 to 20 refers to this information. Ooh, yeah, this question was like very annoying. All right, I'll try to make this as easy as I can. So Jen bought a box of crunchy grain cereal. So the nutrition facts, 1 serving size. So I'm just going to write that out. 1 serving size corresponds to 3/4 cup, 210 calories, 50 from fat. Okay, so 50 from fat. In addition, each serving of cereal provides, oh wow, there's so much going on here. So 100, so this is like the nutritional facts. 100 milligrams of potassium. Is potassium K? Chemistry people, I haven't taken chemistry in a while. I think I remember potassium might be K. And this is 5% of your daily allowance. Cool. All right. Now, what they're saying here, so question 18. So we got 3 questions involving this. If P% of an adult's daily allowance of potassium is provided by X servings of crunchy grain, which of the following expresses P in terms of X? All right, so this one's a proportion. Oh, potassium is K. Awesome. Yeah, go chemistry. So P%, I'm going to write P% of an adult's daily allowance of potassium is provided by X servings. And now think about what we just said before. Each serving, so like that's basically the same thing as saying 1 serving of the cereal provides 5% of the daily allowance. Okay, so that allows us to say that this was all for 1 serving, that 5% of the daily allowance corresponds to 1 serving. So you see how like all the units match here. So it's like the percents just kind of like cancel out and the servings cancel out. And now we just have P over X equals 5 over 1. All right, I don't need to cross out the units, but like they essentially cancel out. So I could just say 5 times X is equal to P times 1. So P equals 5X, choice B. All right, this one is like, just read carefully. They have so much information in these questions. Like, just take your time to extract it. So this was a proportion, but that was a hard proportion. All right, on Tuesday, Jennifer will mix crunchy grain. So that's the cereal. So we'll just write that over here. So she has crunchy grain with super grain. Oh, wow. So there's another cereal, super grain. So super grain and crunchy grain. Let me just separate these two. Let me actually do that again. And I'm probably unnecessarily precise there, but whatever. I just want it to look nice. Super grain provides 240 calories per cup. So 1 cup is, 240 calories. Okay. If the total number of calories in 1 cup of the mixture. Okay, so now we're going to mix. All right, so it's mixing time. If the total number of calories in 1 cup of the mixture is 270, how much super grain cereal is in 1 cup of the mixture? All right, so we got to think about this. So crunchy grain, they told us 3/4 of a cup corresponded to 210 calories. All right, so let me just, move that over. So, and I'll change colors here. Let me go in blue. So they told us 3/4 of a cup was for 1 serving. I'm sorry, 3/4 of a cup was 210 calories. I could say the one serving, but whatever. The servings don't matter here. So what I want to do though is set up an equation. So I want to know how much is in 1 cup. So I would actually take this and I would multiply both sides by 4/3. So I'll do that over here. Like if I have like, yeah, 3/4 of a cup equals 210, make space, 210 calories. I'm going to multiply both sides by 4/3. Okay, and then this cancels, and that's 1 cup. So this will tell us 1 cup corresponds to 210 divided by 3 is 70, and 70 times 4 is 280. So 1 cup is 280 calories for crunchy grain. So then we could set up this equation here, like total calories. Let's say there are, I'll use C and S. So 280 C is how many calories come from the number of cups of crunchy grain. Plus 240 calories come from each cup of super grain, and I'll call the number of cups of super grain S. Okay, but they said the total number of calories is 270. But another thing they told us here, if the total number of calories in 1 cup of the mixture, so that means that C plus S has to equal 1. The number of cups of crunchy plus the number of cups of super grain has to equal 1. All right, that's why we have a fraction for an answer. So we're solving for how much super grain cereal. So we're solving for S in this system. Okay, so we can do this a few ways. We could do elimination, but actually elimination would work. You could do elimination or substitution. It's up to you. If we want to solve for S, I guess we could eliminate, yeah, we'll eliminate C. So we'll multiply everything here by negative 280. So we'll have this system. 280C plus 240S equals 270. That equation we'll leave alone, but this will be minus 280C minus 280S equals minus 280. Now we add these cancel. 240 minus 280 is minus 40S equals 270 minus 280 is minus 10. And now divide by negative 40. And this will tell you S is equal to 1/4. So 1/4 of a cup, choice B. 19, let me just, yep, 19 is B. Hard question, for sure. All right, which of the following could be the graph of the number of calories from fat in crunchy grain cereal as a function of the number of 3/4 cup servings? Well, remember what they said before. They said that 50 calories are from fat. All right, so 1 serving, so we'll just write this all out. 1 serving is like 3/4 of a cup, and there's 50 calories from fat. So this is a direct proportion here. And just know, direct proportion, your graph is going to start at the origin, and it's going to like either, it's going to go up. All right, so as X goes up, Y goes up. Like you could go backwards here, but in word problems, it only makes sense to look in quadrant 1, like as, quantities are going up and stuff. All right, in some word problems, like you could go into the negative if you're talking about money. But yeah, this is like what I'm imagining for direct proportion. Direct proportion is something in the form of Y equals KX. So now, read this one more time. Which of the following could be the graph of the number of calories from fat as a function of the number of 3/4 cup servings? So it's a function of the number of servings. So basically, like if you had 1 serving, you're gonna have 50 calories from fat. Okay, but if you double this, 2 servings, it would be 100 calories. Okay, so you see here, like 0 servings, 0 calories. So that's why 0, 0, and then like 150. We're starting at 0, 0, and this thing's going up. So that's why choice A is our answer. All right, so that's the idea for 20. What is the difference between exponential and linear, and what words will tell us if it's exponential and linear? Good question. So exponential, it's kind of like compounding. So this is more like multiply by the same amount. Okay, where linear is a constant rate of change, which is like, you add, subtract the same amount. All right, so, something like, let's say you had a list of numbers like 2, 4, 8, 16, 32. This I would say like, oh, that's y equals, let's say 2 to the x. That's exponential because these are all powers of 2. It's doubling each time, times 2 across. Whereas if you had like, 2, 4, 6, 8, 10, this is like a y equals 2x situation, linear. Okay, so that's the difference. Because yeah, notice here we have an exponential function h. So right away, I know it has to be in the form of like, I'm like, okay, constant, a constant to a variable power like this. So they're telling us y equals h of x has a y-intercept of d. Okay, and d is a positive constant. So I drew it above the y-axis because of that. And did they tell us anything here? Let's see. Oh, all right. So remember, it's a constant to a variable power. So you see how we have this is a constant power here. So this is a constant power, which means it's not exponential. So that one's out. This is linear because d is constant. 3 times a constant is constant. So this one is linear. So this is out. And now d to the x or 3 to the x. The problem with A, I just know it's going to be choice D. And it's because they told us that the y-intercept is D. So what that tells us is that when we plug in 0, so h of 0 is D times 3 to the 0. And 3 to the 0 is 1, so I have D times 1 is equal to D. So you see like the point 0D is on this graph. A is no good because if you plugged in 0, this would give you negative 3 times 1, which would be negative 3. And they told you D is a positive constant. This is a negative constant. So A is out. So it's got to be choice D. It's pretty late. It is 10:10 right now. So I only started it so late because my kids will hopefully stay asleep for this. If I do it during the day while my kids are home, it'll just be way too loud. And plus, when they're awake, I want to be out there like hanging out with them and stuff too. So yeah, I'm a math teacher, dad, husband. Like I have a pretty busy life. YouTube I usually do at night. During the school year, I only do YouTube at night. But in the summer, if I have both kids out, then I could do YouTube during the day. So the live streams I did over the summer, like both of my kids were not home. That's why I changed the time because like one of my sons was with me today. So yeah, I was like, all right, we'll hang out together, and then when you go to sleep, then I'll do YouTube. All right, so the weights in pounds for 15 horses in a stable were reported. The mean, median, range, and standard deviation for the data were found. The horse with the lowest weight, all right, blah, 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 was found to actually weigh 10 pounds less than its reported weight. Which value remains unchanged? Okay, well, the average, like the mean is the average. So, I don't know. Let's say the horses were like, I don't know how much horses weigh. This is going to be embarrassing. I'm going to pick something like way off. Whatever. Let's say, what's 500? I'm just going to look it up. So I wish I had a farmer here. How much do horses weigh? 1,500 to 2,200. All right, I was way off. All right, so 1,500. All right, so Snapple fact, 1,500 to 2,200 pounds. So 1,500, and then let's say the next horse is like 1,550, and so on, like all the way up to like, I don't know, let's say like 2,000, and then sure, the biggest horse is 2,200. The thing is, when you find the mean, you're finding the average. So if this one here was like actually like, it was 1490. So 1550 and everything else remains unchanged. That's going to definitely destroy the average. Or not destroy, but it's going to lower the average. Okay, if we're off by 10. So that will change. The answer is actually going to be the median because the middle value is going to be unaffected. Okay, because notice that it was the lowest value that was changed. So that doesn't change anything. The range is going to change because it would be like 2200 minus 1500 now becomes 2200 minus 1490. Like those are different numbers. And the standard deviation, this is like the average, like in a way, it's kind of like the average distance from the average. Okay, so like this value, like now is going to be like this is further away from the average than 1500. Like this is going to change the average. This changes the average. So like the distance from here to the average is going to change. And even if this distance to the average didn't change, like the other values, the averages change. So like all the individual distances are going to be different. So like this one will change as well. All right, but the middle value is still going to be in the middle because the lowest value is dropped. All right, so that's why it's unaffected. All right, because this, like whatever's in the middle is still the middle. The lowest is the one that drops. So it's like the middle person like doesn't care. It's like, oh, well, my weight didn't change, So if the middle weight dropped by like 500 pounds, then yeah, you're going to have a new median, assuming that horse doesn't have the same weight as another horse. Okay, 23. Near the end of a U.S. cable news show, the host interviewed viewers to respond to a poll on the show's website that asked, do you support the new federal policy discussed during the show? At the end, the show reported, all right, so 28% said yes, 70% said no. And which of the following best explains why the results are unlikely to represent the sentiments of the population of the United States? All right, well, I definitely don't want to open the political can of worms. But here, like a news station, like depending on which news station it is, like there are some news stations that like they really cater to like a specific audience. So like no matter yeah, like I said, I don't want to open the can of worms too far, but basically it's going to be the bias. That if you're like asking a specific crowd with like certain political beliefs, like what their belief is on an issue, and like all the people with the same political views or similar political views are watching the same news station, like they're more likely to vote in unison on an issue. Whereas if you were to go to a different news station where the people have like almost the opposite view of the other news station, then when you interview those people, like for all we know, like the opposite station, the numbers would flip. So I'm looking for bias here. The percentages do not add up to 100, so any possible conclusions from the poll are invalid. No, that's not true. So yeah, that's not true. Those who responded to the poll were not a random. Yeah, so it's not random. The thing is, if you want less bias, why the results are unlikely to represent the sentiments of the whole population, you need a completely random sample. Okay, so you can't just go to like a specific news station where people are like, let's say, more likely to have a certain political stance. So that is the idea. So I just know it's that one. There were not 50% yes and 50% no. Like, no, that's like saying you only want to have a certain layout. So that's not it. The show did not allow viewers enough time. No, that's not it either. That's just kind of off. Okay, so you want to reduce bias. So unlikely to represent because there's too much bias. Okay, it was not random. You need to make it as random as possible. That'd be like saying, like, hey, let's interview students to see what their favorite sport is, but let's only interview kids on the football team. Like, chances are it's going to be football. So just floating that out there. All right. So f of x plus a, what is the value of a? So I would do f of x plus a over here. So f of x plus a. So algebra time. equals 5 times, instead of x squared minus 3, we replace x with x plus a. And now, please don't say this. All right, please don't do that. All right, x plus a squared. You should be doing this. All right, I do this in my head. I just go to like, all right, 5 times x squared plus 2xa plus a squared, and then minus 3. All right, I just go all in one step. But yeah, if you want, like, just see here, don't forget the middle stuff, like ax plus ax. And then you get the a squared at the end. So these middle stuff, like the middle terms, combine to 2xa or 2ax might be better. Yeah, let me actually just fix that. So I'll say 2ax. Yeah, that looks better. 2ax. All right. And once we simplify this, though, we're going to have 5x squared plus 10ax plus 5a squared minus 3. So this is one of those equating coefficients type algebra questions. So this is this is f of x plus a in terms of a, but they gave us the actual. Okay, so I'm just going to write out, we have 5x squared plus 10ax plus 5a squared minus 3. This is our constant at the end, is equal to 5x squared plus 30x and then plus 42. So there's two ways now we could do this. You could set these equal to each other, 10ax and 30x. That's probably the easiest. So we'll just do that. So that means 10ax has to equal 30x. So here, divide by 10x. And a equals 3. So 24 should be choice C. If you set these equal to each other, the algebra is just harder. 5a squared minus 3 is the constant. Set that equal to 42. And that gives you 5a squared equals 45 after you add 3. And that gives you a squared is equal to 9. So here, the only catch is, like, I know you're like, oh, a equals plus or minus 3, but then you'd have to plug in to see if it satisfies the middle. So the middle one is just easier. That's the more direct one because there's no square attached. So that's why I set the linear part equal. Alrighty, moving on here. I'm still on horses. 1,500. Wow, horses are heavy. If I said 500, I guess, I mean, I was off. I almost said like, nah, they're definitely more than 500. Why did I say 500? I guess because I go to the zoo a lot with my kids and I see ponies, and I haven't seen like a strong horse in a while. They used to be in Manhattan a lot, but now, like, I think they phased them out. I don't know. All right, sine of x degrees equals a. Which of the following must be true for all values x? So draw this out. And I'm going to write this as a over 1. Fix that. So a over 1. So if x degrees is here, so there's our x degree angle. Remember, SOHCAHTOA. So cosine is the ratio. Oh, wait, I'm sorry. Don't get old. All right. I accidentally looked to the answer as like the question. Sine of x degrees equals a over 1. So x degrees is going here. And SOHCAHTOA. Sine is the ratio of the side opposite over the hypotenuse. So that means this I could label as my opposite side, and this is my hypotenuse because we're dealing with sine. So I have a over 1 like this. So now, what we could do with this information, which of the following must be true? Well, just so you know, 90 minus x refers to this angle. Okay, because if I had some triangle, let me draw it over here, right triangle, and this is, let's say, 20. These two angles here have to make 90. Because you see how, like, this angle is already 90. So I have, like, 90 plus 20 plus, I'll just put, the x is taken. I'll use y. Plus y equals 180. Like, this would tell us, like, y is equal to 70. But notice, 70 and 20 are complementary. So I could just say like, oh, this angle is 90 minus that angle. If I just did 90 minus 20 right away, that would also give me 70. So if you just know that, like that saves you a lot of time because you don't have to go through exactly what I just did on the side. All right, it helps to know that this is like the other, this is the other acute angle. All right? So cosine of x would be not equal to a. Like this thing here, like this is not like this part is not necessarily like this is not necessarily isosceles. Okay, you could have a triangle where like this one is longer. So like these like are not equal. Okay, like you could have like 5, 12, like 13 or something. Like I know this is 1, but like divide everything by 13. And you see like these are not equal. So this one's out. Sine of 90 minus x is same thing as this. Cosine of 90 minus x is the 1. Cosine of 90 minus x is cosine of this angle here. And you see adjacent to that angle is a. So cosine of 90 minus x, cosine of the other angle is the side adjacent over the hypotenuse 1. So it's this one. You could, plug numbers in here with, sorry, it's just like been sitting here for a while and my neck is, tightening up a bit. I don't know. This is like a thing for my 30s. All right. I got to like stretch every now and then. Is sine and cosine are cofunctions. So that's one of those like ideas. If you know it, it's just really awesome. I'm going to go to degree mode to show you what I mean. So sine and cosine are cofunctions. If I have sine of 70, I know this is equal to cosine of 20 because 70 and 20 add up to 90. They're complementary. See how I get the same ratio? So if I had like sine of 55, I know 55 plus 35 is 90. So those two angles plugged into sine and cosine give me equal ratios. So that's just something I know, that like this angle x and this angle 90 minus x are complementary. Okay, so that's just like a nice little piece of math that helps in occasions like this. But if you don't know it, you could still like figure things out. It's just going to take you longer. But that's a question I could do fast because I know cofunctions well. All right, so the quadratic function above models the height above the ground, h in feet of a projectile x seconds after it has launched vertically. Okay, so I'm just going to draw this out. So it's starting here at 10, and it's going to go up and it's going to go down because it's a quadratic and has a negative in front of the x squared. I know h of 0, if I plug in, is just going to give me the constant at the end 10. That's how I know it's starting at 10. It's going up and down. And I'm not drawing this to scale. So which of the following represents the real life meaning of the positive x-intercept of the graph? So that's this one here. So that would be like if it's, think about it, it's a projectile that's being launched. It's going to be the time it takes to hit the ground. Okay, because if this is time or x and then h of x. I wish they would use t, but whatever, they used x. T is better for when you're talking about time. So here, at x equals 0, like 10 is the initial height. So the like this would be the y-intercept, not the x-intercept. The maximum height of the projectile is not here. It's at the vertex, not the x-intercept. So this would be vertex. So applications of quadratics. The time at which the projectile reaches its maximum height is still like vertex. All right, and that would be like if you had x equals negative b over 2a. That's like this idea. So it's the time it takes the projectile to hit the ground. Okay, because here you're at like a height of 0. So it's like the projectile goes up and it comes back down. All right, cool. Did I circle the answer? Yeah, so 26 should be choice D. 27. All right, so we're making decent progress here. We are cruising through. Let me just check the chat. I've been on the horses for a while. So let's see. Oh, nice to have you on. At RyanTube. Hello. I'm glad. Lena, keep these up. Videos helps. Oh, thank you so much. I appreciate you giving me the shout out there. Thank you. I appreciate you saying that. And to anyone taking the SAT, once again, good luck tomorrow. I was wondering if you're using a graphing calculator or a scientific calculator. Honestly, I think this is like one of the better calculators to bring, like something like this, because just in case you need to graph something, it's like just handy to have. The basic calculators will do it, but these I find are like more geared towards the high school classes. Middle school, you could get away with like out having like the graphing feature unless you're taking algebra 1 as an 8th grader. But for high school, like for sure you want to have a graphing calculator. I'd recommend it personally. Like, don't get me wrong, I think doing this test, I didn't graph anything by the calculator, but it's because I know how to graph it by hand. Like, I just know that this is a parabola from experience. So yeah, just an idea. All right, so question 27. I guess let me move a little bit. All right, so the graph of a polynomial function crosses the x-axis at exactly 2 points, and it's crossing the x-axis at a comma 0, b comma 0, where a and b are both positive. So a and b. So roots and factors have an opposite relationship. Okay, that's a big idea for this question. Let me move that over because I think that might have got cut off. Okay, roots and factors have an opposite relationship. So that's how I do these questions quickly. I say, all right, well, if the roots, they told us these are the points A0, B0, those are roots. So that means the factors are going to be x minus A times x minus B. Now, let me just, one thing to be mindful of. A and B are both positive is also important. Okay, so yeah, just be mindful of that our function here, f of x, is going to be in this form here, once again, because a and b are both positive. Like, let's say like a was equal to 2 and b was equal to 4. See how like x minus 2, x minus 4 would give you these two roots. All right, so that's how I know 27 is going to be choice A. All right, x plus b, x minus b. The problem with this is if you set x plus a equal to 0, the root would be x equals negative a, not x equals positive a. Okay, so remember this, before I wrote on it, set a and b. All right, so that would be like if we plugged in. Let me actually get rid of that stuff now that we made sense of it. Okay, so this one here was choice A. All right, but once again, the roots are x equals a, x equals b. So x minus a, x minus b are the factors. That's the opposite relationship. Okay, once again, this one is out because of what I just showed. This one of the roots matches, but once again, x plus b equals 0 would tell you the root is x equals negative b. That's not true. The root is x equals just regular b. And this one is almost good, but it has a third root at x equals 0. So this one crosses at 3 points. Okay, so this has 3 roots, but we need it to have exactly 2. All right, cool. If they had put a square here, though, then it would be tangent, and it would be like kind of like a sneaky question. So yeah, that one, like, because cross means it's going through. If there was a square, this wouldn't go through. All right, that's something you learn like a little bit more in calculus. But I could even just show that if we had like x times like x minus 2, x minus 4, this will go through, 3 times. See, 1, 2, 3. But if I attach a square, so x squared, and then I do all that x minus 2 and x minus 4. See this, now it doesn't go through, it doesn't cross, it's only tangent. That's because we have if we have an even power over the factor x. All right, same thing if I had like attached a square to this. Then it's not gonna go through, it's gonna, see, it's tangent, it goes through, but here it doesn't go through. So that would make it interesting. But then they would have to say like they'd have to, I don't know, that one I think they have to explain like, yeah, tangent versus crossing through, the vocabulary. Oh, the vertex of a parabola, sure. So quick tangent here, pun intended. If we have a parabola, so let me just draw one in space like this. So the vertex, we usually call that hk. So y equals a times x minus h squared plus k. And when you have a parabola, this is usually like, you know, like the standard looking way of writing it. But the vertex, like this here is the vertex. So when you want to find the h value, like the x coordinate, it's negative b over 2a, like this. So that's how you find it. But then if you want to find out what k is equal to like, if you call this like f of x, it's like your f of h. Okay, like you plug h in and that'll tell you what k is. So that's how I think about that. But it's our turning point. All right, it's the turning point of our parabola. Like, for example, if I had y equals, I'll make a nice one, like y equals x squared minus 8x plus 12. Here, I'll make one that actually has roots. Then this one, I know the vertex is going to occur at x equals, like this is, like my a is 1, my b is negative 8, and my c is 12. At negative b is negative 8 over 2 times a is 1. 8 divided by 2 is 4. So at x equals 4 is where my vertex is. This is also my axis of symmetry. Okay, I'll say the vertex occurs at h equals negative b over 2a. All right, this is also the axis of symmetry, x equals 4. So if I go back to this and I graph, let's see, x squared minus 8x plus 12, you could see at x equals 1, 2, 3, 4, that's the turning point. Okay, so it tells us where the turning point is. And if I go to the table and I scroll back to 4 here, you can see 4, negative 4, and the turning point is here. See how we have symmetry to the left and right. All right, you could always press second trace and minimum if it's a low point, maximum for a high point. And you could trace, go enter before, enter after, enter a third time, and you get the vertex 4, negative 4. Okay, if it was upside down, like the parabola going this way, then you do second trace and maximum. All right, so that's my little quick lesson on vertex. All right, at Amy. So let's see here. So a quadratic is graphed in the xy plane. Which of the following characteristic of the graph is displayed as a constant or coefficient in the equation? Oh, so vertex. How convenient. So the vertex occurs at x equals negative b, so negative 6 over 2 times 3. So at x equals negative 1. We could, of course, just use a calculator here. But let's just see. It helps to be able to do this with formulas and with the calculator. Like, you never want to rely too much on the calculator. You want to be able to think as much as you can on your own, because that even gets you better at the calculator. So you see here at negative 1, negative 1. Okay, that is our vertex. So our vertex is at negative 1, negative 1, which does not show up anywhere. So the y coordinate of the vertex, they're saying which of the following characteristics of the graph is displayed as a constant or coefficient. So we need, like, what I'm thinking of here is we need to look for like 3, 6, 2. One of those numbers, a coefficient or constant. So the x-intercepts, those are the roots. So let's see, what are the roots? We have a calculator. So we look at the roots here. We have a root at, looks like negative half and negative 1.5. But those values don't show up. Notice they're all constants. There's no decimals or fractions. So this is out. The y-intercept, what is the y value when x equals 0? Is equal to 2. And 2 does show up. x-intercept of the line of symmetry. Well, if we look at this, the x-intercept, this is going to hit at x equals, does that go on this? No way. Wow, that worked. That is a game changer. Wow, that was a happy accident. I didn't even realize that was a thing. How cool is that? That is so cool. Sorry, I'm just like amazed that that is possible. That changes everything for my next, you know, live streams and stuff. All right, let me get this now over here. So if we look here at x equals -1, like that would be our x-intercept at x equals -1, which is not one of those numbers, 362. So that's why it's the y-intercept, which occurs here at 0, 2. So the y-intercept, we're hitting the y-axis at 2. And that is our constant at the end. It's a weird question, though. Very weird question. All right. So moving on here. We have a scatter plot. Whoops, too far. A little better. Okay, we're in. All right, we're getting there. Less than 10 questions to go. And 2 hours in. All right, not so bad. Just for the record, I know like some people have commented like, hey, you should do it in the time that you are allowed. But I did this before the live stream, and I did the first section, the 25-minute section, I did in 13 minutes. And this one I finished with like 5 or 6 minutes to spare. But I really took my time on the second section because of all the reading. It's like so much reading. So I didn't really feel the need to rush for 29. Not that I rushed through the first one. It was just like the questions are so algebraic. It's just like, all right, boom, algebra. The reading questions, you just want to make sure you don't step in any bear traps. So the scatter plot shows the federal mandated minimum wage every 10 years between 1940 and 2010. And here's the equation. The line of best fit is this equation here. What does the line of best fit predict about the increase in the minimum wage over the 70-year period? All right, so let's think about this. The minimum wage is Y. Okay, so this is like our Y is the minimum wage. And years since 1940. So each year between 1940... All right, let's think about that. Each year between 1940 and 2010, the average increase in minimum wage was $0.096. Oh, okay. All right. I see. It took me a second to see like what the idea was for this question. All right. So, because it's like reading comprehension, like you got to like kind of read this and understand it. So you really have to know what slope is. Slope is the rate of change. So they are leaning into the rate of change here. So the slope is 0.96. But think about what the units are. It's minimum wage. So dollars per hour. So that's your rise. Over your run, units are years since 1940. Okay? So it's the minimum wage. So here it's the increase in and it's increasing here. So we have the minimum wage in dollars per hour per years since 1940. So that means like notice it's like years since. So this is essentially saying like the minimum wage in dollars per hour is increasing 0.096 dollars per hour every year since 1940. All right, so each year between 1940 and 2010, the average increase in minimum wage was $0.096. Like this right away I can see is the one. The problem with this is the fixed amount. Okay, so this is like this is fixed, the y-intercept. That doesn't vary. So each year, the average increase in minimum wage was 0. No, that's our y-intercept. The rate of change tells you the increase or decrease. Every 10 years. All right, so this one was same idea, like they used the y-intercept. C is the next best answer. And the trap for choice C, the bear trap here, is they're saying the minimum wage every 10 years between, like that this was a scatter plot showing the minimum wage every 10 years. But notice that we have an equation here, and this equation, the y equals, so this is just so you really get the concept. This equation works for all x. Okay, so this works for x equals 1, x equals 2, x equals 3, x equals like 3.5 even. Like this is like a continuous line here that has any value of x that we want from even like 0 to up to 70. Okay, so the slope of the line is like the rise over the run, but it's per year. See how it's like years since. So this is like per year. So that's why it's A and not C. All right, this was like they were confusing you. They were just describing the graph like, hey, our scale. This is talking about the scale. This is not talking about the slope. All right, so little trap. Nice question. All right, now I got to be honest. 30, if you waited this long and you heard me in the beginning, is the question I missed. My mistake, this starts at 10. My assumption was when I was identifying the y-intercept of this line, I was like, oh, it's a little bit more than 400. So like probably going to cross out these two. Oh, I'm sorry. Wait. It's starting at around 400. So that was bothering me like right away. Like, wait a minute. It's starting at about 400 and I was thrown off. I didn't see here that it was going here. So what I got lazy because I was just moving fast. I was like, all right, it's probably this. The better move here, I did find the slope between these 2 points, which then kind of stalled me a bit. So this point here is like roughly 12,500. So you see, I did get one wrong, but it still counted as an 800 because that was the only question I got wrong. But I'll show you like where my thinking went. I was like, wait a minute, the slope is 800 minus 500, roughly over 22 minus 12, because it's like which of the following could be an equation of the line of best fit. So this is 300 over 10. So like roughly 30. So I'm like, all right, the 30 slopes, like if it's going through those points, the slope does not lie. But what was bothering me was like, wait a minute, like this is kind of close to 400. So I'm thinking C, but like I was like, whoops, that was my trap. All right, my bear trap was that this starts at 10, not 0. All right, why I was lazy here was I should have took the time to use this equation. If I had used this equation, then I would have been good. All right, or if I even used this one and solved for the y-intercept. But I was lazy. I was like, you know what? Like let me just keep moving. I should have treated it like as seriously as possible and say like, no, don't leave anything. Like now I know, like check what is the y-intercept. So now if I use that 22,800, the slope being 30, I use mx plus b. So I have I am approximating like around 30 times the x value here. Let's say I use the one where it's 22. Not that it matters. So mx plus, oh, actually I would have to write this out even. See, I'm even getting lazy here. If I do it this way, y is 800 equals 30 times x is 22 plus b. So I would just do 800 minus, that would give me 660 equals b. And then this one, though, gives me 140. So it's like still debatable, like, oh no, which one's better? But if I use their slope of 33, okay. Wait, did I just write 20? Oh yeah, 22. So if I use 33 instead. So let me do that. If I use 33, so I'll use those numbers instead. I would have 800 equals 33 times 22 plus b. Because if I use the answer choice, that's going to be as precise as I could get here. So let's just see. I would have 800, or it would get me closer, minus 33 times 22. So now I get 74, which is close to 84. All right. So that's the most reasonable one. All right, so that was, but look, this was a, if I had to describe the mistake I made, it was careless. It's not like, oh no, like you don't know linear equations and whatnot. It was just like, all right, sneaky, you started at 10, not 0. You got me. And I got lazy. It was a combination of like sneak attack and my own fault for being a little bit lazy. So what I learned from that is like, look, no matter what level you are, like, don't cut corners. Like, do the question. You got to do it right. So just floating that out there. Okay. When you have a chord in in the XY plane, the circle has a center HK and a radius 10. What is the value of K? So I'm looking at this. This has a lot of symmetry to it. We have this chord, and what we could say is if I draw in the line like this, so going this way, that cuts the chord in half. All right, so what I have so far, like I know if I draw this in at 90 degrees, that's like immediately where my head goes. That's going to cut this in half. So these are going to be equal. Now we're going from 4 to 20. So 20 minus 4 is 16. If I divide that by 2, that's a distance of 8. So 8, so this would be 8 and this would be 8. All right, so I'm just, putting all this stuff here. The radius is 10. And 3, 4, 5, just like I said before. So 3, 4, 5. If I double it, like K equals 2, let's say I dilate this by a scale factor of 2, this would give me 6, 8, 10. So see how this would be over 8 and up 6. So what's the value of K? Notice we're on the XY axis. That K is going up 6. So the value of K would be 6. All right, if they ask for the value of H, you have to be careful. That would not really use the Pythagorean theorem, though. It wouldn't be as exciting. But it would go 4 plus 8. You see how it's going over 4 and then over 8? So H would be equal to 12 if we did 4 plus 8. But they wanted K because that needs more work. All right, in the XY plane, the line L has a y-intercept of negative 13 and is perpendicular to this. Whoa. All right, so there's a lot going on here, but let me just put this. Line L, I'm thinking y equals mx plus b. They told us the y-intercept, the b value is negative 13. And it's perpendicular to the line. I'm going to call this line M over here, where this, actually line M is actually a bad name for it because the slope is M. How about line P? That letter's not taken. Cool. So the slope of line P, this is line P now, is negative 2 over 3. So if line L is perpendicular to this, the perpendicular slope, we would flip and negate this. So it would become positive and we would flip it to 3 over 2. So now line L, the equation would be y equals 3 halves x minus 13. So now they're saying if the point 10b is on line L, so 10b is like on this line, what is the value of b? So that's your x and your y. So now I have b equals 3 halves x is 10 minus 13. 10 divided by 2 is 5, and 3 times 5 is 15, and 15 minus 13 is 2. So 32 should be 2. All right, 33 makes me realize how little I know about science, which is a little embarrassing. When I hear like Reese's factor, I think of like Reese's, the snack, but that's definitely not even close to the same thing. I feel like the science teachers would all be angry at me right now. All right, so we have the Reese's factor is positive, negative, blood type AB, and then AB, and then O. So human blood can be classified into 4 common blood types. It is also categorized by the presence of positive, negative, by the presence or absence of the Reese's factor. Okay, the table above shows the distribution of blood type and the Reese's, I hope I'm saying it right, factor for a group of people. If one of these people, all right, so here we go. It sounds important. If one of these people who is Reese's negative is chosen at random, the probability that the person has a blood type B. So we're focusing on this row. Okay, so let's look here for now. So once again, if one of these people who is Reese's negative is chosen at random, the probability that that person has blood type B So now I'm focusing here, is 1/9. What is the value of x? All right, well, think it's part over whole. So if a person from the negative row is chosen at random, the probability that that person has blood type B. So there's two people that have blood type B in this row here. Out of, there's 7 plus 2 plus 1 plus x. So this is the total amount of people in this row here. Okay, but whatever this simplifies to, it's supposed to simplify to 1/9. Okay, so now algebra time. This is 2 over 7 plus 2 plus 1 is 10. So I have 10 plus x equals 1/9. And now I could just cross multiply here. So I have 10 plus x times 1 is 10 plus x equals 18. And this will just tell me x is equal to 8. So 8 is our value of x. Nice question. All right. So 34. Based on the graph, so we have number of goals scored by a soccer team in 29 games. This is like a frequency type graph. All right, so number of goals scored by a soccer team in 29 games. Number of goals scored. Based on the graph above, in how many of the games played did the soccer team score goals equal to the median number of goals for the 29 games? Wow, all right. So this one, oh, I see it. So number of goals scored. If one goal was scored in 8 games, 2 goals were scored in 9 games, 3 goals were scored in 6 games, 4 goals were scored in 3 games, 5 goals were scored in 2 games, no games were there 6, and there's only one game with 7. And if you add this up, so you get 17 plus 6 is 23, 26, 28, 29. So these add up to 29 as they should. All right, I see what's going on. So making sense of the question is like a part of getting it right. But now if I think about it, 29 games total. I'm not going to write 29 out because we'll lose our sanity. But I'm going to write this. I'm going to write 14 plus 1 plus 14. All right, so this is, I'm writing it like this because 14 plus 1 plus 14 is 29. So what this tells me is like the 15th game is the median. All right, like if you have like if you write the numbers from 1 to 29, 1, 2, 3, all the way there, like, 14, 15, 16, all the way to, 28, 29. And you keep crossing stuff off. If you cross off the first 14 and the last 14 like this, the middle one is the 15th game. All right, like that's the idea. The 15th game is the median. So when they say here, based on the graph, and how many of the games played did the soccer team score goals equal to the median number? The median is the 15th game. So if we look here, 8 games, they scored 1 goal. So the 15th game is here. See how, and I'm getting there because I know 8 plus 9 is 17. So this is like the first 17 games. So the 15th game is going to be here where 2 goals were scored. So if we look here, in how many games did the soccer team score goals equal to the median number of goals? In 9 games. Okay, in 9 games, they scored 2 goals. And yeah, so the median is in this column here, and there was 9 of those games where they scored 2 goals. If you want to do this brute force, I really don't recommend you do this. You could do this, but you will probably lose your sanity. Is you could actually sit there and go 1, 1 like this, list out 8 ones. So 5, 6, 7, 8. And then you could list out 9 twos. So 3, 3, 3, and then 6 threes. This, though, I think you would lose your sanity. I don't know. I mean, it works. And then 3 fours. And then, let's see, 2 fives and a 7. Like, you could do this, but I really think you're going to lose your mind. And you go like, all right, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And go like, let's see, 1, 2, 3, 4. 1, 2, 3, 4. And you see like, all right, 1, 2, like the median is here and there's like 9, 2. Like you could do it that way, but I don't know. I would feel sad. I mean, I only did that for instructional purposes just to show you that like that's what the question's asking. The median is 2 and 2 showed up 9 times. Weird question, but oh yeah, good luck to everybody taking the test the first time. Thank you, Parth, for sending goodwill to the chat. All right, so Gisela would owe $15,500 in taxes each year if she were not eligible for any tax deductions. Okay, so that seems like an important number, so I'm going to write it down. This year, Gisela is eligible for tax deductions that reduce the amount of taxes she owes by $2,325. Okay, if these tax deductions reduce the taxes Gisela owes this year by D%, what is the value of D? All right, well, first I'm going to subtract 2,325. And I could use a calculator for this, but yeah, why not? I mean, we have a calculator. Why suffer? All right, so 15,500 times minus 13,175. This might not be the move here, but it seems like what I want to be doing. Okay, so for this, she would owe this much if she were not eligible for tax deductions. This year she is eligible, and it reduced the amount of taxes she owes by this. So this is like the new amount. All right, if these tax deductions reduce the taxes Gisela owns by D%, what is the value of D? Oh, all right. I think I see here. All right, so this is like new minus old over old when you're finding percent change. Oh, okay. So, or like you can even say like absolute value, because it should always be positive. Your percent change. Yeah, I mean, unless if you say negative percent, that means it decreases. Positive percent, like it's increasing by that percent. So here, we already just did that. We just did, well, they found the difference for us. So it's like the new minus the olds. Like it's absolute value, so it doesn't matter. Like I could just say 15,500 minus 13,175 divided by the old price. This will tell me the percent change. Okay, so these deductions reduce the taxes she owns by D%. So I want to find out what was the percent change. That's okay. So percent change here. So this, we're basically doing 2,325 divided by the original amount, 15,500, which is 0.15. Okay, so this is 0.15, which is 15 out of 100, which is 15%. Okay, so her taxes were reduced by 15%. So D% has to equal 15%. So this tells us D equals 15. All right, so that's, yeah, basically it. And if you want to check your answer here, you could see if you took the old amount and you take 15% off, if you take 15% off, that means 85% is still on. 1 minus 0.15. I'll even write it out like that. 1 minus, and you get 13,175. Okay, which matches like the deduction of 2325. Cool. So 15. Alrighty. This one, is there a shortcut? Oh, all right. So it's one of those no solution situations. When you're in standard form, so we need lines that are parallel because we want this system to have no solutions, which means these lines aren't going to intersect, which means these lines have the same slope. Okay, so if they have the same slope, that means the ratio of their coefficients are going to be equal. Okay, because you think about it, to solve for y, like if you do y equals mx plus b, that's going to be like, this is like too much time. All right, it's going to be too much time. And what I mean by that is, like, for example, if I have 2x minus 4y equals 10, and then I have, like, let's say, I don't know, 4x minus 8y equals 30. Like, I just know these are going to be parallel lines because, like, the ratio of the coefficients, like, let's say I do, the coefficient of y, -4 over 2, is equal to -8 over 4. This gives me -2 equals -2. And these lines are going to be parallel. If I actually take the time to solve it out, that's like I said, that's going to waste time. I would rearrange this. I would have 2x minus 10 equals 4y. And then this would give me, after I divide everything by 4, I'd have y equals 1/2 x minus 5/2 after I reduce. And then this one would give me, I'd have 4x minus 30 equals 8y. When I divide everything by 8, see, I'd have y equals 1/2 x minus, divide the top and bottom by 2, I get 15 over 4. All right, so you see I have the same slope here. My lines are parallel. There's no solution between them. So I could do that, but like I showed the first time, just finding the ratio of the coefficients and setting them equal is faster, way faster. All right, so let's do that here. So it doesn't matter which way I go. I could do the coefficient of x over y or y over x. Doesn't matter. Let's say I do 3/4 divided by -1/2. That has to be equal to, a over minus b. And I don't even need to bring the minus with us because they both have a minus. So what is the value of a over b? So this side, yeah, like let's say I just multiply both sides by -1. Like I do this. That's going to cancel out the negative. Okay, so now I just have a over b equals. A over b equals 3/4 times, I'm using keep change flip here, 2 over 1. And that's going to give me 2 over 4 reduces to 1/2, and I get 3 over 2, which is equal to 1.5. All right, or I could just do in a calculator. Like I have a calculator here. Like I don't have to do this math by hand. I could press alpha y equals enter and do 3/4 divided by 1/2. And I get 1.5. Okay, either way, we're good. All right, 37 and 38, the last two questions. We're just about there. I am excited to be done with this. Yeah, this is a lot of questions, and they're hard questions too. So these are not easy to explain either. All right, so we have international tourist arrivals in millions. And so where are tourists going? In millions. All right, and there's an increase in travel to most of these countries, except China, and China. Yeah, China reduced. Everywhere else went up. Okay, based on the information given in the table, how much greater in millions? So how much greater in millions was the median number of international tourist arrivals to the top 9 tourist destinations in 2013 than the median number in 2012 to the nearest 10th of a million? Okay, so we have to find the median. There's 9 countries here. So if I start crossing these off, like 1, and they're organized from least to greatest, so that was polite. We don't have to reorganize this. So 2, 3, 4. So Italy, you are the winner. Okay, so Italy is the median, and we want to look here at these values and answer how much greater in millions was the median number of tourist arrivals in 2013 than 2012. So just subtract 47.7 minus 46.4. And we could use a calculator for this, but this is like not too bad. 7 minus 4 is 3. 7 minus 6 is 1. So 1.3 million. Okay, so to the nearest 10th of a million, and this is in millions. And this is, 1 digit after the decimal. So we are good. All right, so moving on here. Final question. We made it. All right, I'm excited to be done. The number of international tourist arrivals in Russia in 2012. So now we're focusing on Russia. Okay, so the number of international tourist arrivals in Russia in 2012 was 13.5% greater than 2011. So notice 2011 is not even here. Okay, but it's 13.5% greater. The number of international tourist arrivals in Russia was K million more in 2012 than 2011. What is the value of K to the nearest integer? Okay, so we have to see how many millions of people went to Russia in 2011. So there was a 13.5% increase. Just know 13.5% is 13.5 out of 100, and that is 0.135. Okay, you can even just type that in the calculator. It'll give you this decimal. I'm thinking of this formula here, like A equals P times 1 plus R to the T power. Like this is kind of the idea that I'm going to use. So we want to know like how many people were in Russia. So people 1 plus 0.135. If I do 1 plus this, I'm going to get 1.135. Okay, and then this is going to be equal to, so whatever the population was in 2011, so this is like whatever P is in 2011, it increased to 24.7 million. Okay, the population, like the amount of tourists. So to solve for what is the P value here, the population of, how many tourists went, I divide. So first I solve for this. So let's pull up the calculator, and we're doing 24.7 divided by 1.135. Okay. And we get 21.762. So P equals, don't get old. I'm kind of tired too. 21.762. All right. So 21.762. But they didn't ask us, like, what is the value? Like, don't write 22. Okay. The actual question is the number of international, well, let's read this part again. The number of international tourist arrivals in Russia was K million more in 2012 than 2011. What is the value of K to the nearest integer? So now we have to subtract 24.7 minus 21.762. Okay. And to the nearest integer, I just know it's going to be 3. So the final one here is 3. But if I was like, oh no, it's the SAT and I want to get like the best score I could get, I'm doing 24.7 minus, and then I just go up to my previous answer, press enter, and 2.93 rounds to 3. Okay, so 3 is the nearest integer. So about 3 million more people went from 2011 to 2012. So 3. All right, so that is the end of this practice test 9 review, all right, for both math sections. Just let me just see here. Monitoring the chat. Once again, to anyone who was here live, thank you so much for supporting the live stream. To anyone taking the SAT tomorrow, or if this is at some point in the future and you're watching the replay, good luck to you. All right, do your best. I could make like a test taking tips video in the future. I'm not going to go through that now because I could talk a really long time about that. But I think I definitely, covered enough ground here. Hopefully you picked up some new tricks or ideas for approaching these questions that maybe you didn't have before. So yeah, once again, good luck to everybody and thank you for stopping by. So take care.